Hello guys, happy new semester inshallah with Calculus 3 and all of your courses. Do you hear me?
Yes, doctor.
Yeah, I'm Ahmed Al Sambati, your instructor for Calculus 3 this spring semester inshallah. Your lecture will be on 5. According to your schedule, we'll meet face-to-face after 2 weeks inshallah. We'll go online these 2 weeks, as you know. As for the book, you don't need to buy a new book. The book of Stewart you have already for Calculus 1 and 2 is our book for this course as well. It is Calculus 3. It's all about 3 chapters, chapter 13, 14, 15. But we need to revise some of the geometry in chapter 11 and 12. Our TA, Dr. Kamal, will help you in that. We'll give you some time for solving exercises every week, and we'll have some time this week and the coming week for revising the geometry in vectors and geometry in chapter 11 and 12. We'll have a worksheet for every lecture. You will solve it in 10 or 15 minutes every lecture and submit it on the lecture time. For these 2 weeks, you will submit it online to Dr. Kamal. On the same day of the lecture. Your homeworks, or I mean your web assignments, will be submitted on due dates. You have it on the syllabus. Everything is determined and specified there. My office hours will be from 2:30 to 3:30 every Monday and Thursdays. I'll be happy to meet you and hear your questions on my room 1051 on the mathematics department. Any questions? Any expectations? Anything you like to say before we begin with mathematics? Do you hear me?
Yes, doctor.
Okay. Kareem, Hannah, Farida.
Yes, doctor.
Catherine,
Doctor.
Marwan, Ahmed Saeed, Omar.
Yes, doctor.
Yes, doctor.
Do you hear me? Any questions? Okay, I have another lecture before your the time of your lectures from 3:30 to 4:45. If your schedule is suitable, you can attend the other lecture before this time. I'll come to your class as determined and prescribed in your schedule. But if it's better for any one of you to attend the other lecture, you are welcome. No problem at all. But I need you to go every lecture and every week with your practice of examples and exercises, and prepare for submitting your web assignments, because it will not be accepted late. The course is nice and it is not very long. It was the previous syllabus was containing chapter 16 as well, which is a bit long. It's all about 3 chapters: vector functions, functions of many variables, multiple integrals, as you see. I need to hear you first, and when we'll go for section 13.1. to be ready for your first exercise sheet. Farida, Hannah?
Yes,
Kareem?
doctor.
Yes, يا دكتور.
Any question?
لا.
Any expectation for calculus 3? Okay, let's go slowly together with the
Doctor, is there going to be a WhatsApp group or not?
yes, there is. There is one. It's called Calculus 3 Spring 2022. It will be sent. It is there in the syllabus. I sent the address to Dr. Rafi, our supervisor, our course supervisor. It will be there in the Blackboard as well. Everything will be available, inshallah, soon.
Okay, thank you, Doctor.
Welcome. Anything else? Okay, you are used to calculus from secondary school. I know you studied most of the time function of one variable. Y is a function of x. Y depends on x. So we have 2D curves. We have this xy plane. We have 2D curves. Y function of x. It may be a circle, maybe a line in the plane. It may be ellipse, maybe parabola, like this. This is parabola, you know. This is another circle in the 2D. So we are used to calculus of one variable. This is all about calculus 1 and 2. Today we'll begin about calculus 3. What is new in calculus 3? What do you expect? How to generalize these concepts of calculus 1 into more general situation. In calculus 1, I said we are used to have input x and get output y. This is what we say about y function of x. But today we'll begin with vector functions. What is vector functions? It is this R vector. This is the notation for vectors, this one. Or according to your book, they write it this way. They write it bold. They write bold R for vector R, and don't put this sign. But it's not easy for us to write this bold in handwriting, so we put the notation of vectors as you are used to. You studied vectors in the chapter 11 or 12. We need to revise that as well. We need to revise the dot product of vectors and its meaning, the cross product of vectors and its meaning. What is the result? Is it a scalar or a vector? This will be revised. We need to review this. And Dr. Kamal will help you in doing that. There will be special online sessions for this revision. What's here, what we'll deal with in chapter 13 is a vector function R, which is a vector X, Y, and Z. All of them depend on variable T. So the independent variable here is T. Think of it as time. Think of T as representing the time. So the input here is T, and the function F will give you the output as a vector function. X of t, y of t, z of t. So think of it as, instead of one function of one variable as in calculus 1 and 2, we have the output 3 functions of one variable t. So what is the geometry of this? It will be a moving particle. If you think as a particle moving in space, x, y, 3, this is 3D, x, y, Z space. So we have the axes for X and Y and Z. Think of the moving particle drawing a curve in space, like a rocket, like a plane, like a missile, and so on. It's moving and drawing, while moving, drawing a curve in space. This curve may be a circle in XY plane, may be an ellipse, you know the ellipse, elliptical curve, like the orbit of the Earth around the sun is elliptical. This is a plane curve. It is elliptical. This is a plane curve. Maybe a space curve like the helix. This is a helix. It's the particle is trying to move in a circle, but before it completes its cycle, it goes up in the Z direction. So this is a helix or helical curve. We have trillions of helical curves in our bodies, in the cells, because it is the structure of the DNA. You know the DNA. This great discovery of biology in the 20th century, its geometry is 2 helical curves. So this is not a plane curve, it is 3D curve. This is what we are going to study in chapter 13. We are going to have 3 functions at once, 3 functions in one go. We are given an independent variable t. It gives output x of t, y of t, z of t. What is x, y, and z? It is the point. It is the point of the moving particle. This point is drawing a curve in space. This curve may lie in one plane or may not lie in one plane as the helix, as I mentioned. This is what we are going to study in chapter 13. So think of 3 times calculus 1. So we have 3 functions in every example. We have 3 functions. We need to study what we studied before in calculus 1, how to determine the domain of the function, determine the limits of the functions, determine the derivative, slopes of tangents to the curve, and integration of the curve, and what does this mean physically as in calculus 1, but 3 functions in one go. This is the first generalization we are going to study in calculus 3 to deal with vector functions. Input one variable t, output 3 functions, which are the coordinates x, y, and z. Second, we are going to study in chapter 14 many variables as input. So the input here is x, y, and the output is z. Or x, y, and z as the input, and the output is w. So w is a function of x, y, and z. So you can think of many applications of this. So many things depend on more than one variable. Even the simplest situation is if we have a rectangle, so the area is the length times the width. So xy, a equals xy. This is a function of 2 variables to calculate the area of a rectangle. And many other examples, temperature, the many situations we need to deal with many variables. This will be the case we are going to study in chapter 14. In chapter 15 will be our last part of the course, will be multiple integrals. Multiple integrals mean this notation. Integration with respect to x and with respect to y. Triple integrals with respect to x, y, and z. We'll come to this later. So let's begin with our first example, what to expect to have. We are given this. I begin with example from calculus 1. Any question before I begin example 1?
No, doctor.
Okay. Okay, let's have an example from calculus 1 to begin with and to see how to generalize our case. If you have a function like this, square root of 2 minus x squared, the question is to find the domain of f. What is the domain of f? The possible values of x. What? The real values of x, which makes y real. Any question? Any answer for the question?
When 2 minus x squared equals or more than or equal to 0.
Yes, or equal to, because we have it in the numerator. Exactly, this is right. For y to be real, we have to have the radicand bigger than or equal to 0. Because why is this? Because this is important. Sometimes we have the situation of imaginary values in the question, and we have to exclude them. Because if we have negative value under the square root will be imaginary. Root of -1, -2, and so on. This is not real. Fine. So how to complete this solution? Someone else, please. Please participate.
You
Will be
move the
fine.
2 to the other side, and then you divide by -1, and then you take the root of both sides, which is going to give you boundaries. So it's going to be less
Yeah.
than or equal to the root
Okay,
of.
exactly. But can you go step by step?
Okay, you move the 2 to the opposite side by subtracting 2
What?
from both sides.
What
You
we get?
subtract.
Wait.
You get. Okay.
X squared is what?
Less than or equal to 2.
Exactly. Then what?
Then you take the root of both sides, so it's going to
Then
give you
what we get? What we get?
x is greater than the negative root.
Like, let's say this one.
Like there's greater than or equal to on both sides of the x. So it's
Okay,
going to
why
be,
is that? Why we get we get two sides of x? Because when we take the square root, we get the absolute value. We get the absolute value. The square root of x squared is the absolute value of x. This is important. Less than or equal to square root of 2. This is the point. So what are the points? Whose modulus, or this is the origin? Here, where are the points? Whose distance from the origin is from, yes, exactly, negative root 2 to.
And then positive root 2.
Yes, exactly. So we get these two bounds. So the domain will be domain F will be this closed interval from negative root 2 up to root 2. Exactly. This closed interval. What happens if we change the situation into the reciprocal of F to be the new function G? What will happen? This one. What is the difference? The difference is we have the square root now in the denominator. So this is
That shouldn't be not equal to 0.
Yes, exactly. So we have to be, we have to have this as 2 minus x squared. The difference is this will be bigger than 0. No equal sign. The 0 should be excluded because it is in the denominator. We'll give 0 in the denominator, which is not allowed. What will happen? The same solution as before, but we get the x between negative root 2, both sides without the equal sign. So we get the open interval, this open interval. This is the domain of G. It is open interval. Some books write it in this way, which is a bit confusing with the coordinate notation of points, but it is okay, it is understood. understandable. So whatever you are used to, I will be happy with it. But if this is written, you need to be sure that you understand what's going on. So this is the domain question about function of one variable. We now have vector function. Vector function means R of t, R is the vector. What is R? You may study it before, you may have studied it before in physics or dynamics. It denotes the position vector of a moving point or a moving particle. So R of t is the function here. It depends on the input t, the independent variable t, but we get what is the output here? The output is 3 coordinates, x, y, and z. X of t is this first function. Second function is y of t, the given logarithm of t minus 2. And the third coordinate here is z of t. So the moving particle here is going through these coordinates at every point of time t. The question is to find the domain of this function R. How to find the domain of R here? So as we revise this domain of one variable, function of one variable, here we have, I'll make some changes in the problem. Let this be t minus 3. Yes, go on. Who can participate and help?
T greater than 3.
What is that? Why greater than 3? Why you need it to be positive? Is there a square root?
Because it cannot be equal to 0, the denominator.
Exactly. We need only to exclude the 0 from the denominator. Exactly. So domain of x is what? R except for 3. 3 to be excluded. Is positive, negative is fine, but the 0 is not fine. What about the logarithm? Who can remind us with the domain of the logarithm?
Less than 0, less than 1. Shouldn't be less than 1.
Okay. This is the exponential function as you studied in calculus 1. This is y equals e to the x. This is its inverse is x, y equals ln of x, ln x. This is the logarithm of x with to the base e, the natural logarithm. What do you notice from this sketch, from this graph? That the logarithm is defined only for positive values. So the argument of the logarithm must be positive. Otherwise, logarithm of 0 is not defined, logarithm of negative is not defined. This black curve is to the right. Got it يا شباب؟
ايوه تمام يا دكتور.
تمام. يبقى هنا عشان to find the domain of y, the second function, we need to say the argument t minus 2 must be positive. T minus 2 must be positive. Cannot be 0, cannot be negative. So t is greater than 2. So this is the domain of y. The domain of z is no problem at all. You know the sign function is defined for all numbers, negative, positive, 0, big, small values. All of the values can give rise to acceptable argument for the sine and cosine, but not for the 10, because the 10 is sine over cosine. So there is a division, so there is a problem. So domain y is open interval from 2 up to infinity. Domain z is no problem at all. Now we can find the intersection of these domains. The common part. When x and y and z are all defined, so we need to satisfy all of these criteria. This one, you need to satisfy this, and satisfy this, and satisfy this. this does not put any constraints. Z cannot does not ask for any restrictions. So who can tell us the answer? You need to have x bigger than 2. Any x bigger than 2 is fine. Any t bigger than 2 is fine for y. But not any t for bigger than 2 is fine for x. There is one problem. We have to exclude what?
Oh, it will be t bigger than 3.
No, not bigger than 3. Bigger than 2, fine, but not 3. Here the excluded point is only 3. So from 2 up to infinity except for 3. Got it?
مش ممكن اقولها برضو t bigger than 3.
You removed one whole part. You removed the interval from 2 to 3.
Yeah, okay.
Okay, let's put it here. 3 is not allowed here for x. Here is from 2. All of this is fine. This is for x, this is for y. Z has no problem at all. So all of this part is the domain except for the point 3. This to be excluded. It is the domain of x, intersection domain of y, intersection domain of z. We have to exclude all the excluded things from x and y and z. So what we get? 2 up to infinity except for 3. Or we can write it in set theoretic notation, all of t such that t is bigger than 2, but not equal to 3. That's it. This is end. You can write end, letters or comma or logic connected. Any problem? All of you understand this? Okay. The answer you suggested is to take from 3 here. So from 2 to 3, what's wrong with them? There is nothing wrong with them to exclude. So you didn't get the whole domain. So this will be wrong. So we need to cancel this. This is the idea or the problems you need to practice on from your book and the web assignment. The domain, it is the revision of the domain. Domains you studied for one variable function. Now it is one variable function, but we have output 3 functions, x and y and z. It is a vector function. Now we go to, after the domain, we go to limits to ask for the continuity and derivative and the integral. This is what we are going to study the coming lectures one by one. Derivative, integrals, and the meaning of this stuff in vector functions. So let's have an example in limits. Who can help? So again, as the domain of vector functions is the intersection of 3 domains of 3 functions, the limit will be the limit of the x function, the limit of y function, the limit of z function, of the vector functions given. So we are asked to find the limit of this vector function when t goes to 0 or approaches 0, tends to 0. So we take these 3 limits. So we take 3 limits at once. So you can think of calculus 3 as multiplying calculus 1 by 3. That's it. The particle or the point was drawing a plane curve. Now it will draw a space curve. So I ask you now to remind us with the formulas we need to have to find these limits. Who can help? Please try to participate.
If the limit is 0/0, we'll apply the L'Hopital rule.
Yes, that's great. When we have 0/0 here, sine 0 is 0, t is 0. Yes, we can apply L'Hopital's rule. In the third one as well, we have 0/0 because e to the 0 is 1. 1 minus 1 will give you 0. 0/0. We can apply L'Hopital's rule exactly. So, L'Hopital's rule, which is limit f over g give you 0/0, so you can find the limit using the derivatives. Limit f prime over g prime. This is L'Hopital's rule. Limit the derivative of the numerator over the derivative of the numerator. The numerator up and down. Denominator down. We have another important formula as well for the sine angle over the same angle when this angle is very small. You need this even in physics and other courses. This is 1, but be sure that theta is measured in radians. So let's find, and the generalized form of this is sine a theta over theta when theta is very small, tends to 0 is a. And you can find it by L'Hopital as well. Even if there is a logical fallacy here, because the L'Hopital's rule was not known when we find this limit. But no problem. We can use it to make our life easier. Who can tell us the result? Limit sine 2t over t.
2.
2, exactly. Using this corollary of limit sine theta over theta or L'Hopital's as you like. The second limit, it does not need L'Hopital, does not need any formula. Even this is very similar to a known formula, but does not work here because this is not 0/0. So this is not 0/0. So we need to make direct substitution first. What we get? What we'll get is 0 minus 1, it's minus 1, over 0 minus 1 is again minus 1. So this is no problem at all. The third limit is limit e to the t minus 1 over t. This is L'Hopital's. So it's limit. I didn't find it yet.
ثانية يا
So-
دكتور. limit in the middle اللي هي t cubed minus 1 over t power 4 minus 1 مش المفروض ان دي تبقى 0 over t؟
Why? I
يعني-
make substitution. T is 0.
اوكي انا كنت فاكرة تمام thank you.
It's very similar to a known formula, but does not work here. I know why it makes a problem. There is like this, Tn minus An over T minus A when T tends to A. This is 0/0, and the formula, this is known very important law of limits. This will give you 0/0, but the final result will be NA to the N minus 1, which is the origin of the formula of derivative, Nx to the N minus 1. When you put the power down and decrease the power by 1. But the condition is that this is 0/0, but we don't have 0/0 here. Got it?
Yes تمام thank you
Yes.
يا دكتور.
Okay. Third one. Third one, we need to write limit because we didn't calculate it at once. We need to do L'Hopital's. T goes to 0. Here we make derivative with respect to t. So we get e to the t, derivative of e to the t is the same, minus 0 over 1. Now we calculate, substitute, direct substitution again, we get the result, 2, 1, e to the 0 is 1. So this is the result. Why we write it this way? Because it's a vector. It's a vector function. So the vector functions tends to a vector. So we can make some comment to say this means the moving particle begins when t tends to 0, when we are near to the time 0, near to the point 211. This is the geometric meaning of what is going on here in this limit. Or we can say it in using vector notation. Or the initial point was having the position vector 211. What is the difference between a point and a vector? The point is the point, you know the point. Point P, point A, whatever. Like in 2D, I explain it in 2D case. The point A is 21, written in this way, but the vector A, or write it bold this way, and you can use the IJ notation as well. The difference is the point A is only the point A, but the vector A is the position vector OA, which means the directed line segment from the origin O to the point A. So it is all of this directed line segment going from O to A. But you mean when you speak of points, so this is only the point. So they are related and there is one-to-one correspondence between them, but I need to clarify the language we use. If you use the point, you use this notation. You use vectors, use this notation. I mean the difference between these parentheses and these brackets. This is for points. This is for vectors. Is it clear? So, what we think of vector functions, we think of one variable function, depending on a variable, one independent variable t, which most of the time represents the time. We come to another example of application of what we use this vector function for. I mentioned many times now. It is, I'll read the example. It is an application for vector functions. You think of as moving particles. Moving particles, these particles may be rockets, may be planes, aeroplanes, I mean, may be missiles, and so on. So let's read this question. You will have a similar exercise in your worksheet for section 1, which says, will the missile described by the function, this function? So you are given, you are given this function. You are given this vector function describing why it is a vector function. There is no notation for vector, but it is written bold as you see. Bold notation is the one used in your book and the exams and worksheets, because it's easy to make bold notation in typing, but it's difficult for handwriting. So we put the notation by hand as I mentioned. Some people write the vector notation as underline, this one. The question is, will the missile described by this vector function, S of t, given by t minus 1, 1 minus t, and 2, hit the plane described by the function? This is another vector function. This is a plane. Why this is a plane? Can any one of you explain why this is a plane? What is the equation of a plane looks like?
AX plus BY plus CZ
equals
D
D. Yes, great.
ولا نغلط ولا
Yeah,
plus
right.
D equals
You are right. This is the equation, exactly. This is the equation, general equation of a plane in space. Ax plus by plus cz equals d. So it's a linear equation. So first degree in x, first degree in y, first degree in z equals a constant d. Very similar to the situation in 2D when we have ax plus by equals c. This represents a line in 2D. You have many other forms of the equation of line and the plane using the slope and the point and many other forms we will come to in revision, inshallah. So why this can be said to be a plane? Why this is a plane? I see here x equals 5 plus cosine t. I see y as equals sine t. I see z equals 2. Where is the first degree equation here? Where is the linear equation in x, y, and z? Sometimes we have no x or no y or no z or no two of them. We can miss some of the variables here may be missing. So if we have x equals constant is a plane, y equals constant is a plane, z equals constant is a plane. Maybe z missing, so we have only x and y. It's also a plane. So we can have the three variables appearing or two of them or only one of them. In all of these cases, we have planes in space. Where is the plane equation here? Who can see it?
Z equal 2?
Yes, z equals 2. Z equals 2 is a plane. Where is this plane? This is the plane. Be sure you understand this. This is the XY plane, the ground. This is the ground. XY plane. Its equation is Z equals 0. Here Z equals 2 is a parallel plane to the ground up there by 2 units. This is a plane. So what is about 5 plus cosine t and sine t? You know, this plane means it's not meant to be the plane, geometric plane, but it is the aeroplane. There is an aeroplane moving in this vector function. Can anyone describe what is the curve it traces while moving, this aeroplane moving in this plane? Is it moving in a plane? Yes, it is moving in the plane Z equals 2. The airplane is moving in the plane Z equals 2. In which curve or drawing what while moving? I'll show you this. This is very important. We need to be familiar with this stuff from the first lecture. Let's write x equals 5 plus cosine t as given, and y equals sine t, and z equals 2. This is an equation of a plane. Okay. So this airplane is moving in this plane around some curve. Who can tell us about this curve? What is this curve representing? What does this curve represent? Any idea?
دكتور أنا مش فاهمة إيه الكيرف بالظبط، أنهي واحدة الكيرف؟
Okay, there is a plane moving. And its movement is represented by this vector function. Its x coordinate is this 5 plus cosine t. Its y coordinate is sine t, z coordinate is fixed, it's 2. This means we have x, y, and z. When z equals 2, the plane is moving here. Z equals 2 is this plane. The aeroplane is moving in this plane, drawing some curve. Is this curve a circle, helix, ellipse, whatever? This is my question.
Circle.
No, it is not a helix, it is a plane curve because z equals 2. Z is fixed. To be a helix, it needs to be a space curve, z is moving.
Oh, I said circle.
Circle, you said circle. Yes, it is a circle. How to prove that? How to
Because it will be أنا عارفها من تحت بصراحة إن هي cosine square plus sin square equal 1.
Yes,
So it will be x
exactly.
square.
This is the idea. This is the idea. The idea is we have cosine here. We have cosine t, we have sine t. We know the relation, very important relation. Cosine square t plus sine square t equals 1 for every t. So at every moment of time, we have the square of cosine plus the square of sine is 1. So we can get rid of this cosine t and sine t. How to do this? Get separate cosine t and separate sine t and square both of them. How to separate? Move the 5 the other way, other side, square both sides, and sum. Add them. Square, we get x minus 5 is cosine t. Y is sine t. If we square both of these two equations and add them, we get cosine square plus sine square, which is 1. This is an equation of what? X minus 5 all square plus y square equals 1. Who knows what is this equation? If we are in 2D, it's a circle.
أيوة.
Yes, 5 and 0 is the center, and the radius is 1. But if we are in 2D, but we are in 3D, it is the same because it is in a plane. So it is a circle in this plane, in the plane z equals 2. In fact, we can understand it in another way. We can say this in 3D. In 3D, x minus 5 compound square plus y square equals 1 is a sphere. So in 3D, it's a sphere. And the sphere, when is cut by a plane, we get a circle. This circle we are talking about is the circle of intersection of the plane with this sphere. This is a sphere. This is a plane. It's better to write it, to draw it this way, like this. This is the plane cutting this sphere. The plane cuts the sphere in a circle. This circle may be a minor circle or a major circle according to if this plane passing through the center of the sphere or not. If it passes through the center of the sphere, it cuts the sphere in a major circle. Major circle means the biggest circle in this sphere, which has the center of the circle the same as the center of the sphere. Think of cutting the earth by a plane passing through the center of the earth. For example, the equator. Otherwise, if this plane does not pass through the center of the sphere, it cuts the sphere in a smaller circle, having different center, different from the center of the sphere. So what all of this about? The question was, this missile will hit this aeroplane moving in this curve, space curve ولا لا؟ هو ده الكويستشن. This was the question. الإجابة سهلة جدا، أنا بس طولت شوية في الشرح في الكلام عشان to get familiar to be familiar with dealing with such equations of curves and surfaces in space, because this will be our habit in all these lessons to come. So we need to understand this is a missile sent in this curve. This curve is linear, and this aeroplane moving in this curve. The question is, will this missile hit the plane or not? Means, can they be equal? Can they be equal or not? Is the x-coordinate, can the x-coordinate will be the same? Can the y-coordinate will be the same? Can the z-coordinate will be the same at some time? Will they be the same at some time? Or this is impossible and will miss, this missile will miss the airplane? So the answer is very easy. We can do it without all of this geometry I revised. We equate this x coordinates t minus 1 to solve it, put it equal to 5 plus cosine t, and put y 1 minus t equals to sine t. The z already equal. They are already in the same z plane, z equals 2. So the question is to find t at which x is the same and y is the same, if this is possible, or otherwise say this is not possible. Any question? We have many graphs to sketch in this course. We have many curves to sketch in this course. Sketch, just roughly sketching, it's not exact. This is easy, but we need to be familiar with. One by one, just do the practices I ask you to do every lecture, inshallah. Who can participate? Who can help? Please do.
أنا مش فاهمة، هو إحنا like are we supposed to sketch ولا إيه بالظبط؟
لا هنا ما قاليش، بس أسئلة كتير هتيجي هيقول لي، فأنا بقول لكم من دلوقتي. يعني هنا في المسألة دي مش دي in this problem he didn't ask me to sketch. But in many problems to come we'll be asked to sketch, to explain what is this plane drawing, what is this plane moving curve. This plane is moving in a circular curve in the plane z equals 2. Justify your answer. This is what I have done here. It's moving in the plane z equals 2. This is clear. But why it is a circular? We found the equation of the curve. We eliminated the cosine t, the t between them, and get this equation. You said it's an equation of a circle. You said, yes, it's right. It's a circle if we are in 2D, but we are in 3D. It is the same. It is again a circle, but lying in this plane, z equals 2. Now, to answer the question, all of these are about the problem, but the solution is none of these. So now, will the missile hit the plane or not? We're asking, is there a time, is there a solution t which makes x the same and y the same, z the same? That the same is already given, 2 and 2. So we need to solve for t minus 1. Solution is, all of this is revision of geometry and spheres, planes, lines, and this stuff. Solution is there a solution?
I don't think so. هو ازاي تكون زي زد واكس وواي نفس الرقم غير لو زيرو؟
لا مش زد واكس واي نفس الحاجه. الزد هنا هي الزد هنا. ده اوريدي جيفن، دي 2 ودي 2.
تمام.
السؤال بقى، هل الواي دي اللي هي 1 minus t can be sin t in some time and in the same time the x is the same as this x هو ده السؤال. يعني دلوقتي انا عايز t minus 1 تكون هي 5 plus cosine t. t minus is there a solution for t minus 1 the x for the missile, the x for the missile t minus 1, the x for the plane is 5 plus cosine t. Is there a solution for d and the y for the missile is what? 1 minus t. To be the same as y for the plane. ما هو لما الميسايل دي الاكس والواي والزد يعني هتكون عند بوينت معينه اكس واي وزد والبلين عند نفس النقطه دي يبقى هي خبطتها خلاص. يبقى فعلا القذيفه دي اصابت الهدف، اصابت التارجت بتاعها، مظبوط كده؟
So we replace x minus 5 ب t minus 1 و y
ايوه
1 minus t ونشوف equals 1.
دي هتكون هل في سوليوشن تي، هل في فاليو للتي تخلي الاكس دي هي الاكس دي والواي دي هي الواي دي والزد دي هي الزد دي، الزد دان مفيش فيها مشكله. المشكله كلها في الاكس والواي، هل في فاليو تي هنا خلي دي هي دي ودي هي دي، هو ده السؤال. 1 minus t equals what؟ sin t. and دي simultaneously عايزين ده يحصل في نفس الوقت. Is there a solution for this؟ يلا. اللي انا قلته كان زياده وبره شويه في الجيومتري بس هيديني كلو لحل المساله دي. Think about it and give me your answer. مين يحل؟ شباب؟
نخلي both equal 1 يعني نقلب
أيوة
t both.
نجيب ال1 ده منين؟ ايوه نعمل ايه؟
For the first one we're going to subtract t from both sides and then divide by -1. بعدين في the second one we're just going to add t to both sides.
انت خدي بالك دي كوزاين تي ارجمنت للكوزاين. والنوت كانسل مع التي.
مش تكنسل، نخليهم 1 equals -5 minus cosine t plus t. Then on the second equation it's going to be 1 equals sine t plus t وبعدين نخلي sine t plus t equals -5 minus cosine t plus t ونشوف if there's a value that works.
اي الفكره كويسه بس دي ما عندناش ليها قانون فورمولا برضو ولا حل، لان انت عندك مثلا اقول لك حاجه اسهل منها. لو عندك t plus sin t equal مثلا half، تعرفي تحلي دي؟ يعني equation فيها t وساين t سوا. هل دي حاجه ايزي ان احنا تصولف؟ خدتوا نيوميريكال اناليسيس؟ ما اظنش لسه. دي حلها مش ايزي، دي حلها اسمه نيوميريكال ابروكسيميشن، ما خدناهوش اصلا.
انا قلت لو
اللي انت قلتيها اصعب من دي على فكره.
انا قلت ان احنا
اللي انت قلتيها في تي كوزاين تي وبلس كوزاين تي حاجات تانية. الفكره كويسه بس الحل بتاعها مش افيلابل في ايدينا.
ليه؟ مش لو حطينا ساين وكوساين في نفس الناحيه and we squared all of it ممكن
اوكي. اذا كنت عايزه تعملي سكويرنج بالكوزاين والساين وتجيت ريد اوف ذم يبقى الفكره اهي، هو ده اللي انا كنت بقوله.
ايوه تمام.
نرجع لدي بقى ونعمل الفكره دي. مين يقولها؟
طب دكتور ما نخلي التي لوحدها، يعني نعمل تي نودي ال1 الناحيه الثانيه هتبقى
أيوة.
5 بلس كوزين تي بلس 1
نعم.
ونسيب في تاني ايكويشن فهنحط مكان النيجاتيف تي نحط يعني 1 ماينس المكان التي بقى اللي بتاعت الايكويشن اللي فوقيها.
نفس الفكره بتاعتها وبرضه هنعمل سكويرنج بعد كده، بس ممكن يبقى لي كوزاين تي وساين تي فيهم مشكله برضه. بس الفكره معقوله، بس الاسهل من ده كله هو الكلو اللي انا قلته لكم من شويه. How to get rid of cosine t and sine t. Separate them and square and add. بصوا هنا عملت ايه؟ cosine t cosine t separated بقت x minus 5. Sine t separated y. Square both of them. Cosine square t وهنا sine square t لما to be added gave 1. No t more. No more cosine t or sine t. نفس الفكرة، نفس الحركة. This is very important idea انه how to get rid of this cosine t and sine t. طب ما سيتبقى لي t كويس، هو ده اللي بدور عليه.
يعني احنا دلوقتي subtract 5 from the first equation and square.
ايوه بالظبط بالظبط.
بعدها تاني واحدة square both sides and add the top equation to the bottom and replace the cosine squared plus sine squared ب1
ايوه
بعدين
هيطلع لي equation in t or t square. This is algebraic equation anyone in secondary school can solve by factoring or by the formula. This is the idea. Let's do it. Let's do it. From 1, we'll get what? T minus 6 equals cosine t. From 2, 2 is ready. 1 minus t equals sine t. What? This is the idea. The idea is the Pythagorean identity of sine and cosine. This is the most basic identity of trigonometry. This is very important. No exam is free of it. Cannot be. Very important. Oh, this is the idea. T minus 6 all square plus 1 minus t all square
equals 1
equal cosine square t plus sine square t. You can put 1 directly, but I prefer to put it step by step
تمام.
to get familiar with this idea. So we get rid of them. This is an equation in T. Let's expand this algebraic equation. T square minus 12t plus 36. Any idea? This is true. Expand a plus or minus b all square. This is a square plus or minus 2ab plus b square. This is easy. Algebraic manipulation is very easy here. This is 1 square is 1 minus 2t plus 2 square. All of this is 1. This is quadratic equation. Second degree equation in T. We can simplify and solve by factoring or by the formula. Even using the calculator, but to mention the situation. Collect similar terms, 2t squared minus 12t minus 2t is minus 14t. Lastly, we have 30. This will cancel. This one will cancel. This is 14t. This is 36. If I make mistake, please tell me. Yes.
لا
The
تمام.
signs, anything wrong?
لا it's right بس هو do we divide by 2
Yes.
يعني is it easier ولا should we just يعني نعملها زي ما هي كده ولا divide by 2 أسهل؟
لا ديفايد اسهل طبعا. وتقدري تعملي بالكالكوليتور فورا بس انا هحلها بايدي. minus 70 easier plus 18. This is difficult to factorize, impossible to factorize over z. No integers can be multiplied to give 18 and their sum will be 7. 2 by 9, 3 by 6, we cannot be. So we by the formula.
مش هي 9
Formula
negative كده؟
at square plus bt plus c equals 0. We need to know the formula. If you don't know, put it in your cheat sheet to use it minus b plus or minus root b square minus 4ac. Even if you solve it using the calculator, put the formula 2a. Put the formula and comment on the answer. Because the answer is not real, if you get negative value under the radical, this means there is no real time for this to happen. They will not hit. The missile cannot hit this airplane if t is negative, if t is imaginary or negative even. So, what is the solution? Can someone solve by the calculator?
I think it's الفاكتورز هتبقى negative 9 و 2 فكده هتبقى equals ل 9 و negative 2. negative 2 ما ينفعش في التايم فهتبقى 9.
تاني انت قلتي تحليل ايه؟ negative 9 و 2؟
negative 9 و 2 اللي هي t minus 9.
But this is wrong because this is positive. So they have to be the same sign.
Okay.
Even negative 9 and negative 2 or positive 9 and positive 2. Both of them will not give negative 7.
تمام.
I will solve it by the calculator.
Yeah, by the calculator it gives positive 2.39 and negative 2.39.
So I'll take your word and be sure this is 1.
But imaginary numbers.
Okay, let me 1. B is negative 7. C is 18. Exactly. You are right. T is 7/2 plus or minus root 23/2i. This, you know, this i. I is the imaginary unit root -1. Is it? Isn't it? Yes, right. These are what? You said these are not in R. I need you to write and express the meaning. This it means no real solution. Which means what? Therefore, the missile will not hit the plane. I think this is a good place to stop. Any question? Any question, Shabab?
Thank you.
هيبقى في
Okay.
ورك شيت يا دكتور؟
Yes, I will send it, inshallah. Tonight I will
طب
send it.
it will be due when?
Well, should be the same days. Should be submitted tonight. When we meet on lecture room, I'll collect your solutions on the time of the lecture. This is what we used to do the previous the fall semester. If this will change, I will tell you, inshallah. So you have more time for tonight. You have time to submit it
طب
tonight.
ممكن في الاونلاين ليكتشرز يعني ممكن تبقى يعني to be due one day.
No, you have already enough time to submit it the same day. You have time after the lecture. The people of the fall semester, they did not have this gift.
Okay.
So please try to submit it tonight.
ثانية يا دكتور submit ايه بالظبط؟
Solution of your worksheet. I will send you the first worksheet of this section 13.1, and you are asked to solve it and submit it to Dr. Kamal, your TA.
حضرتك هتبعته على الايميل ولا على بلاك بورد ولا ايه؟
على البلاك بورد او على الواتساب جروب. هشوف دلوقتي حاجه.
طب بس هو عشان انا مش على الواتساب جروب فحضرتك ممكن
Yes, I will write it حالا.
واسبمت فين دكتور كمال او
We'll write all of the information, the addresses you need. Okay. If you couldn't do that tonight, I'll tell you. Okay. Any more questions?
No, thank you.
Not at all. You're welcome. Hope you like it and do all of you this course, and will be happy doing this course, inshallah, together. Take care and see you, inshallah, soon. See you on Thursday. Salam.